In Chapter 9, we'll discuss safe facilities, pest management, and imminent health hazards. ANSI, or the American National Standards Institute, sets safety standards for the food industry. The food manager class you're taking today, for example, is ANSI approved. NSF, the National Sanitation Foundation, is accredited by ANSI. NSF is an organization that creates national standards for food equipment. NSF and ANSI standards require equipment to be non-absorbent, non-porous, corrosion-resistant, smooth and cleanable, and durable or resistant to damage. Cutting boards should be made of hard wood, like oak, acrylic, or hard plastic, in order to prevent cross-contamination, and cross-contact softer woods, like pine, are not ANSI or NSF approved to use with food. Stationary equipment should be easy to clean and easy to clean around. To effectively clean underfloor equipment, a clearance of 6 inches is recommended. A clearance of 4 inches is recommended for counter and tabletop equipment. Non-food contact surface like flooring, walls, and ceilings must be regularly maintained, and like equipment, should be non-absorbent, non-porous, durable, smooth, and cleanable. Coving, or coved trim, is a curved sealed edge between a floor and a wall. It gets rid of sharp corners or gaps that are hard to clean. Water and plumbing. Only water that is drinkable can be used for the preparation of food and come in contact with food contact surfaces. Drinkable water is often called potable water. Regardless of where your water comes from, you should know how to prevent basic plumbing issues that can affect food safety. However, when problems arise, a reliable and knowledgeable plumber is essential. All water, plumbing, sewer, and grease trap issues should be handled by a licensed plumber. A cross-connection is a link or connection between clean, safe, potable water and contaminated or undrinkable water sources or systems. This cross-connection can create a backward-moving pressure. Backflow and back-siphonage can be the result of this backward pressure. A running faucet below the flood rim of a sink is an example of a cross-connection. A running hose in a mop bucket is another example. The best way to prevent backflow is to avoid creating a cross-connection. Do not attach a hose to a faucet unless a backflow prevention device, such as a vacuum breaker, is attached. The only sure way to prevent backflow is to create an air gap. An air gap is an airspace that separates a water supply outlet from a potentially contaminated source. A sink that is correctly designed and installed usually has 2 air gaps, as shown in the graphic on the slide. One is between the faucet and the flood rim of the sink. The other is between the drain pipe of the sink and the floor drain of the operation. Good ventilation systems prevent grease and moisture buildup. Both grease and moisture buildup allow for harmful bacteria to grow. Ventilation systems will remove excessive fumes and heat, allowing for better temperature regulation. Good lighting makes it easier to clean things in your operation and provides a safer environment. Many local jurisdictions require prep areas to be brighter than other areas. All lights should have shatter-resistant light bulbs or protective covers. The lighting intensity, how bright the lights are, is measured in units called foot candles or lux. The recommended lighting in the prep area is 50 foot candles or 538 lux. Refuse or garbage containers must be covered when not in use. They should be leak-proof, waterproof, pest-proof, and easy to clean or cleanable. Outdoor containers should be on an asphalt or concrete surface, lids closed when not in use, with the drain plug in place. Pests can present a serious problem for food establishments. We first deny pests access. We deny access by checking all deliveries before they enter your operation, by making sure all of the points where pests can access the building are sealed. Cracks and holes should be sealed with caulk or concrete. Other ways to deny access are by installing air curtains, also called air doors or fly fans, and by having tight-fitting screens on all windows and vents. A second defense is to deny harborage. Harborage is known as food, water, and shelter areas. By controlling garbage, keeping food away from walls and off the floor and counter, and by practicing FIFO, we are denying harborage to insects and rodents. Even after you've made every effort to keep pests out, they may still get into your operation. Insect and rodent infestations can be very difficult to eliminate. Look for droppings or feces, nests, and damage on products. Avoid setting traps and using poisonous or toxic pest control materials. Once pests are discovered, work with a PCO, a licensed pest control operator, to get them under control. Restricted use pesticides can be applied only by a licensed pest control operator. Certain imminent health hazards can severely affect the safety of the food you serve. Common imminent health hazards include significant electrical power outages, significant refrigeration loss, fire, flooding, and sewage backups. Local regulatory authorities consider these significant threats or dangers that require immediate correction or closure. Power failures and refrigeration breakdowns can threaten your ability to control the temperature of TCS food. Unauthorized people inside a facility are a risk to food safety. Fires, floods, and sewage are significant threats as well. And lastly, insect and rodent infestations are also considered imminent health hazards. When faced with a crisis that could cause a health hazard, you must first determine if there is a significant risk to the safety or security of your food. If the risk is significant and cannot be immediately corrected, service must be stopped and the local regulatory authority must be notified. The problem must be corrected, otherwise known as taking corrective action. And as a last measure to ensure the safety of consumers and staff, the shuttered establishment is required to obtain permission to reopen from the local regulatory authority. In our final chapter, Chapter 10, we'll learn about best practices when cleaning, sanitizing, dishwashing, and proper storage of cleaning tools and supplies. Let's begin with the master cleaning schedule. A master cleaning schedule should be reviewed on a regular basis and updated as needed when new equipment is purchased or new procedures are implemented. A master cleaning schedule should include what should be cleaned, who should clean it, when it should be cleaned, and how it should be cleaned. It should be made mandatory for all staff to participate in the master cleaning schedule. How we clean certain surfaces and equipment depends on whether the item to be cleaned is a food contact surface, meaning food will directly touch the surface, or a non-food contact surface, a surface that food will not directly touch. An example of a food contact surface is a plate or a food container. An example of a non-food contact surface is a wall, floor, shelf, or ceiling. Let's begin with food contact surfaces and equipment. All food contact surfaces and equipment must be cleaned and sanitized. These should be cleaned and sanitized when between prepping different foods, after 4 hours of continuous use, or any time a task is interrupted, and the item was contaminated. Remember, food contact surfaces should be non-absorbent, non-porous, durable, and cleanable. Many surfaces in the operation do not normally come in contact with food. These are called non-food contact surfaces. Examples include floors, walls, ceilings, and equipment exteriors. Because they are not food contact surfaces, they do not need to be sanitized. However, they do need to be cleaned regularly. Let's first talk about cleaners, and then we'll talk about sanitizers. Cleaning removes food, dirt, and light grease from surfaces and helps keep pests away. There are a variety of cleaners available, each with a different purpose. Detergents are typically used for dishwashing, baked on food, and light grease. Abrasive cleaners are often used for non-food contact surfaces and heavy cleaning. Degreasers, of course, are used for grease buildup, and a delimers helps reduce mineral buildup. Brushes are recommended for cleaning, while sponges should be avoided as bacteria tends to grow more quickly on sponges. Sanitizers reduce pathogens to safe levels. It's important to note that sanitizers cannot completely eliminate pathogens 100%. All food contact surfaces must be sanitized after they have been cleaned and rinsed. This can be done by using heat or chemicals. One way to sanitize items is to soak them in hot water, that is heat sanitizing. For this method to work, the water must be extremely hot, at least 171 degrees Fahrenheit. The items must be soaked for at least 30 seconds. Chemical sanitizing requires knowledge of chemical sanitizer concentrations. Chemical sanitizing concentration is measured in ppm parts per million. The only way to check a chemical sanitizer's concentration is with a test kit or test strip that is specific to that chemical. Some factors will affect how well your sanitizer is working. If the water in your facility is extremely hard or has extreme pH levels, the effectiveness of your sanitizer can be weakened. Always follow manufacturer's directions for water temperature when mixing chemical sanitizing concentrations, and be sure to rinse detergent off thoroughly. Residue from detergent left on surfaces can also decrease the effectiveness of the sanitizer. The chemical sanitizer concentrations chart shows us the parts per million and time required for sanitizers to be effective. Chlorine is 50 to 99 ppm for 7 seconds. Iodine is 12.5 to 25 parts per million for 30 seconds. Quats or quaternary ammonium is per manufacturer for 30 seconds. And we see once again that heat sanitizing with hot water requires a temperature of 171 degrees and a time of 30 seconds. To clean and sanitize a surface, follow the steps detailed here. 1. Scrape, rinse, or remove food bits from the surface. 2. Wash the surface. 3. Rinse the surface, using clean water. 4. Apply sanitizer. 5. Allow the surface to air dry. A couple of reasons. First, cloth or paper towels might leave behind contaminants, and we know sanitizer needs contact time to work properly. It's important to clean and sanitize stationary equipment. An important safety measure before cleaning equipment is to unplug the equipment. Take off any removable parts. Scrape, rinse, or remove food. Wash, rinse, and sanitize all parts, and allow the parts and surfaces to air dry. And finally, put the equipment back together. Dishwashing machines sanitize by using either hot water or a chemical sanitizing solution. High-temperature machines use hot water to clean and sanitize. If the water is not hot enough, items will not be sanitized. Stationary or single-tank machines must reach a maximum temperature of 165 degrees in order for dishes and other equipment to be sanitized. Automatic dishwashing machines require a sanitizing maximum temperature of 180 degrees. 3-compartment sinks and drain boards must be cleaned and sanitized before being set up. Fill the first sink with detergent and water. The water temperature must be at least 110 degrees Fahrenheit in this first sink. Fill the second sink with clean water. Fill the third sink with water and sanitizer to the correct concentration. Hot water at 171 degrees can be used as an alternative. Provide a clock with a second hand so food handlers can time how long items have been in the sanitizer. Store wet wiping cloths used for wiping counters and other equipment surfaces in a sanitizer solution between uses, as shown in the photo on the slide. Change the solution when it no longer meets requirements for the sanitizer being used. To be effective, operations must have procedures for cleaning up vomit and diarrhea. These procedures must address specific actions that employees must take to minimize contamination and exposure to food, surfaces, and people. It is critical that employees be trained on these procedures. A job aid or poster showing cleanup procedures should be accessible, and personal protective equipment should be provided. We've compiled a list of important numbers to remember. Go ahead and take a minute and read through this chart. Before we begin the review questions, we'd like to share some exam tips. Be sure to read all the questions slowly in order not to miss any important words. Our brains tend to skip over smaller words. Be on the lookout for 2- and 3-letter words and prefixes like not or the prefix non, as those two in particular, if unnoticed, will result in wrong answers. Read all 4 answer options. Often on the exam, a good answer will appear at letter A or letter B, but there could be a better answer on letter C or letter D. Use the process of elimination in order to narrow your 4 answers down to 2 answers. Then reread the question, looking for keywords. In deciding between two answers, it's often better to choose an answer about safety than either quality or customer service. Mark questions for review as you progress through the exam. After completing the last question, go back through the exam and revisit those questions marked for review before submitting your final answers. And one last exam tip: do not leave any questions unanswered. Take your best educated guess. Thank you for choosing Catkin, and best of luck to you on your exam.